Why is water the molecule of life? Have you ever wondered why the human body is 60% water? And why can fish survive under frozen lakes during winter? Or why do we sweat when we get hot? Well, water is often called the molecule of life not only because it exists in all three states naturally and floods 71% of our planet, but also because it is a universal solvent, forms ice with lower density than water, and has a high heat of vaporization. Many of the unique properties of water result from a special kind of intermolecular force called hydrogen bonding. But before we get into that, let's take a closer look at the water molecule H2O. Since the oxygen atom is missing 2 electrons and the hydrogen atoms each has an extra electron, in order to complete their octets, the hydrogen forms 2 covalent bonds with the 2 hydrogens. What's more, since oxygen likes electron more or is electronegative compared to hydrogen, the oxygen atom pulls the bonding electrons closer and acquires a partial negative charge, while the hydrogen atoms are left as bare protons with partial positive charges. This makes water a polar molecule. There's a saying that like dissolves like. This means that the charged particles can dissolve easily in water because they form ion-dipole and dipole-dipole interactions with the water molecules, while hydrophobic or water-fearing substances like oil do not dissolve and clump together. In the human body, fluids such as blood is mostly made out of water and contain lots of particles like sugars or salts that provide us with energy or chemical messengers, and also proteins such as red blood cells that transport oxygen. The charged sugars and salts are dissolved so they can be easily transported to and be taken up by cells. The string of amino acids that make proteins, on the other hand, are folded in such a way that the hydrophobic, non-polar parts are on the inside of the charged parts. If our blood was not made of water, proteins will change shape, lose their functions, and we will die. So what happens when a bunch of water molecules come together, like inside a lake? Because unlike charges attract and like charges repel, the molecules will orient themselves in such a way that each O is closer to another molecule's H. The dotted line represents the intermolecular interaction between them, which is called a hydrogen bond. This little line has many implications. When water freezes and forms a lattice, the molecules become more spread out and decrease the density of ice relative to water. Why? Because in liquid water, the molecules are constantly sliding past each other and making new H bonds. But when the temperature decreases and they jiggle less and less, the molecules settle into a fixed position. Because each molecule has a bent shape caused by the unbonding electron pairs on the oxygen, there's a lot of empty space. So ice can float on a lake and helps to insulate the warmer and denser water below. Imagine if ice were denser than water, like many other substances. Then ice formed on the top of the lake would sink to the bottom and eventually the entire lake freezes solid. If you're a fish, hydrogen bond is a relatively strong force between covalent compounds, so it takes a lot of energy to break the bonds. This can be beneficial when we want to keep our bodies cool during summer. Simply use the excess body heat to evaporate the tiny droplets of water on our skin, so we sweat. When water evaporates, they break free from each other, forming gaseous water vapor. The energy needed to change 1 mole of liquid to its vapor is called the heat of vaporization. For water, this value is 44.02 kilojoule per mole at room temperature. This means that for every 1 kilogram of sweat that evaporates, our body gets rid of 2,444 joules of energy in the form of heat, equivalent to 39 teaspoons of sugar. No wonder exercising is a good diet strategy. Yeah! Thanks for watching. The end!